So the Mbed microcontroller has two general purpose timer. One is called repetitive interrupt timer, and another one is system tick timer. All right, and both of them are actually the counter. All right, just a name. Yeah, all are based on the reference just described. Yes, the counter. But the important thing is this: the Mbed use this for three distinct application. So the first one is the timer, all right, where we can measure the event. All right, first thing is the timer, exactly what we have learned just now, the timer. All right, where we can use to measure the event. Okay, so I will show you an example after this. And the second one is the timeout. The timeout, which call a function after predetermined delay. So the timeout is, if we compare with our phone, yeah, the timeout is just like the what do you call the timeout. The name is timeout, means that if we set the time 5 minutes, right? So it will count down, right, from 5 minutes, 4 minutes, 59 second countdown until you have 0. All right, so that is timeout. Okay, a countdown timer. Yes. Okay, so it will give you interrupt signal, or it will tell you that the time is finished. Okay, so you can set how long the timer you want. All right, how long the timeout you want. All right, 5 seconds, 10 minutes, depend on you. 1 minute, 1 second. All right, so if after time out, so you need to, it will tell you. Okay, so that is timeout. So this is number 2. So number 1 is timer, just a normal timer to measure the event, measure the time duration for an event or many events. So depend. And the second one is the timeout. Timeout. And the last one is we call the tickers. All right, tickers. So tickers is a repetitive timer, means that when you set these tickers for 10 seconds, so every 10 seconds it will give you interrupt signal. All right, means that repetitive timeout. Yeah, timeout is one time only when you set. All right, when timeout, done. Okay, but tickers, it will repeat. Yeah, timeout, give you signal, and is it reset to 0, and it will start to count again, reset to 0, count again, reset to 0. Okay, so that will be the tickers. So that is the free application in the Mbed, and that we will look today. And one more thing is actually what we call the real-time clock. So this one, not all the microcontroller have this. Sometimes you need to buy the external this real-time clock. But the Mbed, you have the real-time clock built in, because the microcontroller is quite big and expensive. Okay, so the real-time clock is inside your microcontroller. The real-time clock is another timer that is used to keep track of time of day and date, and this is actually always run on the independent battery inside your microcontroller. All right, just like your computer. So we'll keep track of the real time. So if you want to get the real time and date, you can check this real time clock, or use this real time clock. All right, so let's go to this one by one. Okay, the first one is the timer function. Okay, So this is the API summary for the timer or the function. So you can start the timer, you can stop the timer, you can reset the timer, you can read, and you can read millisecond, you can read microsecond also. So if you read, means that the value that you get, it will return in second. The value that you get is in second. If you read my millisecond, so it will return in millisecond value. If you read microsecond, so it will return in microsecond value. All right, so let's see. The first one is the how we measure the event. For example, this program, yeah. So how to use the timer in the Mbed. So of course, our program, we start with this, include the Mbed library. This is a must, right? And this is the function, the timer, and our function name is T. All right, so you can name it any name, or in this case we use T. This is how we send the output to the PC. Yeah. So if you have your microcontroller, you can use this. Okay. In the Mbed simulator also can use this. So in the Mbed simulator, when you use this, so I show you now. When we use this, so what we can get is this. Okay, the Mbed simulator. So this, the serial output, this represent your computer screen actually. All right. So when you send using we name it as PC. So PC.printf. So when we printf hello world, so it will send this hello world to your PC through the serial link. Okay, like this. All right. Here, for example, we want to measure how long the Mbed take to send this hello world to the PC. All right, means that we want to measure this event, the duration of this event or this task. Okay, so we can start our timer here. So T dot start. Okay, so start from 0, and T dot stop. Okay, to stop the timer, and we print the result here. Okay, we print the result. Okay, print the result. So this one we can test in our real hardware. Okay, I have my hardware here, my microcontroller, or you can use your Mbed simulator. So let's go back. So this is the program. So just copy. So you can have your PC also, yeah. It's better if you do this together. We do this together so that you can try on your own. All right, you can see what is the problem you face. Okay, so we can run this on the simulator. So where is my simulator now? Here is the simulator. So you can just copy and paste here and run. Okay, and wait. So it gives you 0 second. All right, this is the answer that we don't expect to get. All right, so it should give you some value here. So let's give wait function here. Wait 1 second, for example, and see what happened. Give you 0 second also means that something is not right here. All right. So the first time I test this is also I also get this output So I feel something is not right with the Mbed simulator. So I try with the real hardware where I have here. So let's try on the real hardware. Okay. So in the real hardware, the actual hardware, you need the compiler. So of course now you cannot do this, but let's look at this demo. I have the program already because I test just before the class. Oh, not this one. This one. Okay, so here, so let's say we don't have wait function, the wait 1 second function. This is exactly what the same function or the same program as in the notes. So let's run this. Okay, save, and so I need to use the terminal. So this is the terminal software to read the or to display the output by using the printf. Okay, so you can send the output to your computer by using printf, and this is my hardware with me now. So the program is inside of my microcontroller already. So I just press reset and see what happened. So actually got value 0.0000093 second, or 1, 2, 3, 4, 5, 6, 93 microsecond. All right. So actually the process of printf or sending this hello world to the PC is 93 microsecond. Okay, so means that something wrong with the simulator, but don't worry. You might think that the simulator got problem. I will explain later. Okay, so let's see wait one function. So let's have this wait one function and test again. So run, and let's reset. So I clear this window first, reset. Okay, so the time taken is 1 second. Yes, exactly around 100. Okay, plus the sending, this one, and plus the 1 second. So we have 1 point something second. All right, but using the simulator, we don't get this this value, right? So it seems like the simulator, the timer, this timer function is not work in simulator, but don't worry. All right, I test already. Yes, it's not working in the simulator, but for others it's okay, running fine, no problem. All right, so meaning that in your final examination, okay, the question using the timer function is not likely to be asked, right? Because your simulator is will not work on this, but the tickers and the timeout is okay, just good. All right, you understand what I mean now? You get what I try to say, what I try to tell you. Okay, good. Right, so this function is in the actual one, in the actual hardware, is working fine, working good. Right, you can measure. For example, you want to measure the event, so you can start to measure, and for example, you have many line here. All right, and at the end you want to, okay, you stop, and actually you can get your time value, how long it takes, the microcontroller takes from here to here. All right, so you can measure actually using the timer function, but in the simulator it won't work, huh? So don't worry. Okay. All right, so we from the timer we go to the next one, which is the, so this is okay, eh? So when you run using the simulator, you cannot get the answer, right? Because that is the because the simulator is just a software developed by 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 the developer to simulate the hardware. All right, so it's definitely got bug there. All right, got problem. Not everything is perfect. So sometimes it won't work. All right, so that's normal. Okay, but uh, it's tested on the actual hardware already, and it's worked fine. No problem for this one. Okay, so let's look at the this timer fast and timer slow. I think this one can it work. I'm not sure. I haven't tested this one on the simulator, but on the hardware is working good. So, but I don't want to show this. Let's go to the timeout. Yeah. Okay. Later, if we got time, we try to do this. Yeah. So timeout. So how to use the timeout? So the timeout is just like I said. When you set the timeout, when means that you start the countdown function. All right, so if you set time out, for example, for 5 seconds, so after 5 seconds it will give you the interrupt and tell you that, oh, time off, the time is out. So you can do what you want to do after the time is out. The time is up. Okay, so so this is the function. So you can you need to attach the attach. I show you what is attached after this, attach microsecond and detach and so on. So for example, go to this program. All right, let's say we have this. Okay, if I can draw this on here, so let's see the, okay, all right, so let's okay, so let's say we have our microcontroller, and we have 3 LED. 1, 2, 3. And we have one button. Okay, this is power supply 3.3 volt, and we name this as button. And we have what? We have LED 1, LED 2, and LED 3. So we have LED 1, LED 2, LED 3. Okay, so the this application work like this. Wait, yeah. So LED 1 will always blink. Okay. So the application is like this. So when we not press the button, so the LED 1 will always flashing, flash. Okay, every how many second? Every 0.2 second. So this will be flashing every 0.2 second. And when we press the button, all right. So just imagine if we run the program. So this LED will flash every 0.2 seconds. So we blink every 0.2 second. And when we press the button, so this LED 3 will turn on very shortly, very short in very short time. Okay, and after 0.2 second, I need to go back to program to see 2 seconds. Sorry. So after two seconds, when we press the button, all right, this LED 3 will immediately turn on. All right, and after 2 seconds, this LED 2 will turn on. Okay, so we use the timeout function, all right, to measure the timer. So when we press the button, we start the timeout function, and after 2 seconds, after the timeout, the 2 second is done, finished. So this LED will be turned on. Okay. So so to get the idea, so let's go back to the program and try to run on the simulator first, so that we can see. Okay. So let's use the simulator. All right. You can have this, and you can have one button, push button, and connect to P5, right? Exactly, connect to P5. Okay, so let's run this program so you can see the things. Okay. All right, so when I'm not doing anything, all right, do nothing. So this LED 1 will always flashing every 0.2 second, because this is inside the main loop, right? So let's look at the main loop, the while one, the main, this is the main, and the while one. So the loop is from here to here, means that your microcontroller will always do this. All right. So and here it will test the button. So in this case, the button is not pressed. All right, because I'm not pressing anything here. Okay, so the button is not pressed, so it will skip this and it will do this, right? Else, so LED 3 equal to 0. So this is LED 3. Okay, so nothing. And because I'm do nothing here, so what the program do is, yeah, this is keep flashing this LED. So it will test. So LED toggle. This is toggle. So if not on, yeah, if off, it will on. If on, it will off. Toggle, right? LED 1 equal to not LED 1. Okay, so this will toggle the LED, this LED, and every 0.2 second. All right, but when I press the button here, for example, so what the program do? So when I press the button, when the button is equal to 1, so we will attach the timeout button, timeout function here. So how to attach the timeout function? This is the way, right? So first you need to have the timeout function. Can you see here? I'm not sure whether you can see or not because the font is very small here. Yes, yeah, good. Okay. So you need to have your timeout and name your object, your timeout function as response or any other name that you want to use. All right. So name can be any name. Okay, timeout. So this is how we use the timeout function. Okay, response, which is this name. Okay, this name, we need to attach to the function. Okay, and here we also need to point to what you want to do after the timeout is overflow, or the time is up. For example, in this case, we set the time out 2 seconds, means that after 2 seconds, what you want to do. All right, so in Mbed, you need to specify. So how to specify? This is how. All right, by point to the function. So in this case, this is how you point to the function. All right, point to this Bling function. So what is the Bling function? So here is the Bling function. Okay, so the Bling function, what you do is you on LED, LED2 means that you on this LED and you wait for 0.5 seconds and you off, off, and then you go back. All right, you go back. So let's see. So when I press, I should expect that this LED, when I press, right, LED3 immediately will on, and after 2 seconds, this will happen. Okay, again, I repeat. When I do nothing here, so this will keep blinking or flashing. All right, because of this, it will skip this and it will do this LED3 equal to 0, of course, equal to 0, and toggle LED1, yes, every 0.2 seconds. So see, but when I press button 1, I will attach the timeout function, and the timeout function we set 2 seconds. After 2 seconds, it will go to this function and do this. Do this will turn on the LED2, and after 5 seconds and 0.5 seconds, it will off. And when I press also, immediately the LED3 will turn on. All right. So let's see. Okay. Let's see. I press LED. This LED will immediately turn on, and after 2 seconds, this LED will on for 0.5 seconds. Let's see. Click, immediately on. After 2 seconds, this will on for 0.5 seconds. Right? Again, I press, this immediately on, and after 2 seconds, this will on. Yes, exactly. All right. So that is how the timeout is implemented or is used in Mbed. So let's see, we change this to 5 seconds. 5 seconds, right? 5 seconds. So we should expect that after we press the button, after 5 seconds, it will go to this function, right? After 5 seconds. So let's run this program. Okay, so when there is no press here, so this is still blinking because of this. And when I press, I should expect that this LED will immediately turn on because of this. And after 5 seconds, it will do this. Let's see. Okay, on 1, 2, 3, 4, 5. So should turn on. All right. After 5 seconds, again 5 seconds, it should turn on. Done. All right. Okay, clear? So that is how we use the timeout function. So remember, when you want to use timeout, what you need to do is you need to declare here the name for our timeout function, and you need to attach. You want when you want to start your timeout. In this case, you start your timeout whenever you press the button. So again, when you press, you start your timeout. Okay, so you start here, and how long is your timeout? Okay, in this case, it's 5 seconds. All right, and again, you need to remember that when you use timeout, you need to attach to the function. Means that if timeout, the microcontroller want to know what you want to do. All right, so in this case, after 5 second timeout, the microcontroller need to do this. Now let's say we have a longer time here, right, in this function. So we see this is blinking every 0.2 seconds. So, and when we press the button, after 5 seconds, we need to go to this function and do this. Means that this is not blinking every 0.2 seconds anymore. Actually, wait a little time to see that clearly. Let's change this to 3 seconds, for example, again, right? So if we change this to 3 seconds, and let's see. Okay, run. Nothing happened. So when I push this button, so again, wait. So here, see, kat sini, here is not blinking. It's not blinking when the here is not blinking when we are doing this, right? When we are doing this, again, I press. Okay, after 5 seconds, this will turn on. When this turn on, you see, this is not blinking anymore. Again, and ready again. 5 seconds. Okay, you see. All right. Why this happened? Because here we use the software timer, and here also we use the software timer. Correct. Here we use the software timer, and here also we use the software timer. And when you use the software timer, it cannot run at the same time. All right. When you do this, your microcontroller need to finish this. When your microcontroller do this or execute this, your microcontroller need to finish this. Okay. So when you press the button, after 5 seconds, it will go to this. Your microcontroller need to go here. So when your microcontroller go here, it will not doing this. All right, it will not do this. So if the LED is on, it is always on until you finish this, and then go back on again. All right, that's why you have something like this. Okay, you press. So wait, your microcontroller will go to the do this, and because this is off, so it will continue off until go out from this function. All right, so that's because you use the both of here you use software timing. Okay, so to avoid that, maybe you can use the hardware timer. Okay, so you can use hardware timer by improving the program here. Okay, so the program we have actually, so this program is the improved version of this program, where in this case, let's copy this and run in our program. Okay, Oh, not this one. Wait, is it this program? Okay, we want this program, and this program will finish here. Just copy and paste everything here. So this is the program. So let's see now when the response is after 2 seconds, and this is 3 seconds also. You can have 3 seconds, and let's run. Okay. Now you see the function is the same, and here is running using still using the software timer, because we use the wait function. So here is the software timer, still the software timer. But now the here, this part, we use the hardware timer, all right, instead of software like this one. Okay, so when we press the button, okay, this will on very fast. And yes, although this is on, you see this one is still blinking. All right, still blinking. All right, because this one run independently of this. Okay, see, right, still blinking. It looks like this one is not affected by this process, right? Right. So can you see the difference? Okay. So let's see what we have done in to the program in this case. All right. What you have do is actually the application is actually the same. The only difference is that we implement the function, this function, to on the LED2 here using hardware timer instead of software timer like this. Okay, so what we do is this. Now the main loop is this. Okay, see, the main loop is very simple. You on LED3 and you off LED3 and you toggle LED1. So this one means that this one is blinking and this one is off. All right, and it will continue do this forever, right? But you have this. You have this. What is this? This is button rise. Familiar with this? This is interrupt input, right? Interrupt. So right button here, you see, you assign to what? Interrupt in. You set this button instead of before this you use if. Okay, before this you use if means that you keep always checking the button, but here you're not always checking the button. All right, the microcontroller will respond to the button whenever the button is pressed only. All right, because you set this as the interrupt input. All right, number one. Okay, so this is rise respond when the rise time, the rise time of your interrupt input. All right, so it will go to ISR1. So where is ISR1? This is ISR1. So in the ISR1, what you do is you on LED3. All right, you on LED3. So this one, and then what you do is you attach this to the timeout. That means that after 2 seconds, after 2 seconds, after you press the button and then wait for 2 seconds, you need to do this. You need to go to this function Bling. So where is this Bling function? And this is Bling function. This is Bling function. So when 2 seconds, you go to Bling function. What you do in the Bling function? You do in the Bling function is you turn on LED 2, this one. And again, remember previously, you on LED 1, LED 2, you on and you wait for 5 seconds, right? And you wait here, you wait using software timer. Okay, means that this one will not run. All right, your microcontroller will do this only. Wait. Now, in this case, instead of doing that, you attach, you use another timeout. All right, to means that after 3 seconds, you call another function to turn off the LED number 2. Okay, so means that in this case you wait using this function, means that your microcontroller need to wait here. But in this case, instead of doing this, you just turn on LED 2 and you turn on LED 2 and you go back to do this. Actually go back to do this, and after 3 seconds you go to Bling and you just turn off. All right, so it will be something like this. Yeah, I explain using the flowchart maybe. All right, so let's use flowchart to explain this. So your main program is here. So what you do, you off LED 3. So your flowchart will be something like this. You start, this is your main program, and you off you off LED 3, and what you do, you on toggle LED 1. So we can say that we toggle LED 1. LED 1, and we wait for 0.2 second, and we go back. We always do this. We do this, and do this, always repeated. All right, so what do we do is we off LED 3. This is start. Okay, off LED 3, toggle LED, wait 0.2 second, and go back, do this again and again and again. All right, but once you press the button, actually what the microcontroller do is that it will jump to the ISR. Yeah, jump to the ISR. The name is what is the name? ISR1. So ISR1. So the ISR1 is another part of your program which is not included in your main loop. All right, so your microcontroller will only go to the ISR1 whenever the interrupt occur. All right, when there is an interrupt, so your program will jump to the ISR. If no interrupt, it will always in the main loop. Okay, so when you go to ISR1, what you do is you do this. Based on this, what you do is you ISR1, you on LED 3. On LED 3. So this is on LED 3. Okay, and you do what? You set the timeout. So you set the timeout. Set timeout equal to how long? 2 seconds. So you set the timeout. equal to 2 seconds. And after 2 seconds, you need to go to what? You need to go to this Bling function, right? So where is your Bling function? So this is your Bling here. Where is it? Here. Here's your Bling function. So you need to go to Bling function. After 2 seconds, and you see your interrupt is just like this, and you need to return to the main program here. So means that when you in your program is run like this. Okay, start off LED, toggle, wait, and go back off, toggle, like this, always. But whenever you press the button, so it will go to the ISR1 very fast, very fast. All right, it actually stop from doing this thing. For example, the interrupt occur here after you toggle. The interrupt is occur here. Actually, your microcontroller stop doing this for very fast one, and go to the interrupt and do this on LED 3 and set up the timeout. But because your microcontroller is very fast, it run in for example the Mbed, the frequency is 100 about 100 megahertz. So means that the instruction run is the clock, the period of the clock is 10 nanoseconds. So for example, the instruction is executed in maybe 100 nanosecond. This depends. So means that this one is 100 nanosecond, this one is 100 nanosecond. Means that this is executed very fast. You will not notice this thing. All right, you will not notice the difference in time. All right, you just feel that this thing is always run forever, although your program, your microcontroller actually go to do this, and it's actually do very fast, 100 nanosecond, 100 nanosecond, and then go back. So you, because 100 nanosecond is very fast, you cannot notice the changing. All right. So then again, right, here after 2 seconds, what your program do? After 2 seconds, what your program do is actually again this. If you go back to program, not this one. After 2 seconds, you need to go to this Bling, right? So this Bling is this on LED 2. So you have another function called Bling. All right, and what you do is you just on LED 2, and then you set another timer. The name is timeout number 2, right? You set another timeout is equal to 3 seconds, right? In this case, 3 seconds equal to this is too small, so make it bigger. The name is the timeout is 3 seconds, and the name is Bling N. Okay, so after 3 seconds, you go to Bling N, and you go back. Return. Okay, so this also, it happened very fast. All right, so the microcontroller after 2 seconds, for example, after 2 seconds, again it's happened here. Yeah, it happened here, somewhere here after this function. All right. So after, oh, sorry, here, this is the Bling function. So we go to on LED 2 and set the timeout equal to 3. The name is, and after 3 seconds, we go to Bling N and return. So let's, for example, yeah, again, our main program is running here, all right, and somewhere here we press the button, so it will jump very fast to this IR1, do this on LED 3, set the time out, and when time out equal to 2 seconds already, it will go to Bling, okay, and return. So because not 2 seconds yet, so it will return and go back to do this. That's why you see that the LED 1 flashing is continuously flash, just like nothing happened. All right, and when 2 seconds is done, all right, here for example, it will go to Bling and turn on LED 2 and set timeout number 2 and set it 3 seconds, respond in 3 seconds, and you need to call another function called Bling N and return. And again, because this is very fast, it will go back to do this, and you will see that the LED is still blinking. All right, blinking. And after 3 seconds, what the microprocessor do is jump to the last function. The name is Bling N. Okay, and not N, with Bling N, and what you do in Bling N? Bling N, where is it? Bling N, you just turn off the LED, very easy. So off LED 2, and then you just return, go back to your main program of LED 2, and then return to your main program. Okay, so here is the last one. So again, let's see. Again, the flow is like this. So this is your main program. So it will always run here, so that you see that this one is always Bling here, because your program is running here. All right, running here. So without going to any function here until you press the button. When you press the button, what happens is, when you press the button, for example, it can be anywhere of your program, can be here, can be here, can be here, or can be here. So for example, here you press the button, so your microcontroller will very fast jump to ISR1 and do this, and go back to this again and again and again, very fast. That's why when you press here, still flashing. All right, and again, when you are in ISR1, you actually set time out here. Means that after 2 seconds, you need to force your microcontroller again to go to this Bling function. So when you press, it will turn on this, and it will go back, and just 2 seconds after you are here, it will jump again to the Bling. So it will on LED 2 and set another timeout. All right, Bling N, we name it Bling N, after 3 seconds. So it will on LED 2. That's why when I press, after 2 seconds, again press, after 2 seconds, this will on. All right, for 3 seconds. For how many? For how long? All right, for 3 seconds. Yes, for 3 seconds. Again, press. So for 3 seconds. Okay. it will go back to do this, and after 3 seconds it will go to the blink end and turn off the LED. See, press. So after 2 seconds it will turn on, after 3 seconds it will turn off. All right, so in this way, this demonstrates that how the hardware timer is implemented with the software timer. So in your program, you can have software timer, you can have hardware timer. All right. So depend on your application. So with hardware timer, you can have create many timer that is run independently from your program. So you can while you are waiting for other tasks to finish, so you can do something else actually with the hardware timer. All right, any questions so far? So that is the timeout. So we have around 20 minutes more. Okay, before we finish. Any question? So you can always refer back to this video, yeah?